I'm Kimia Hosseini. This is my network project presentation for Professor Mehrasma's network course. For this project, I implemented inter-VLAN routing using the router on a stick method in Cisco Packet Tracer. So, before starting the configuration, let's understand the objective of this project. This project demonstrates how to create multiple VLANs, separate network traffic logically, configure trunk links, implement router on a stick, enable inter-VLAN routing, and test communication between VLANs. This is the topology used in the project. We have one Cisco 2811 router, one Cisco 2960 switch, and 6 PCs. The PCs are divided into 3 VLANs. VLAN 2 contains PCs 0 and 1, VLAN 3 contains PCs 2 and 3, and VLAN 4 contains PCs 4 and 5. And as we know, each VLAN represents a separate broadcast domain. So now let's have a review on the definition of a VLAN. VLAN, as we all know, stands for Virtual Local Area Network. VLANs logically separate network traffic. Each VLAN is a separate broadcast domain. Devices in different VLANs cannot communicate directly, and VLANs improve security, network organization, and broadcast control. Now let's talk about access ports configuration. End devices such as PCs connect to access ports. An access port belongs to only one VLAN, and in this project, specific switch ports were assigned to VLAN 2, VLAN 3, and VLAN 4. For example, Fast Ethernet 0/4 and Fast Ethernet 0/5 are dedicated to VLAN 3. And here I have brought a screenshot from the switches CLI, and the result is related to show running config from the switch. And we can see in these lines that interfaces Fast Ethernet 0/2, 0/3, 0/4 until 0/7 have assigned as access ports. And according to this script, I think we can say that they have assigned correctly and working properly. Now let's talk about trunk port configuration. The connection between the switch and the router is configured as a trunk link. A trunk port can carry traffic from multiple VLANs altogether. And this is important because we only have one physical connection between the switch and the router in my project. And without trunking, the router wouldn't receive traffic from all VLANs. So, and here I have brought a diagram related to trunking. Now, I'm gonna talk more specifically about the router on a stick method. It allows multiple VLANs through one physical router interface. And I have used this method to divide one physical interface into logical subinterfaces, and the names of the subinterfaces I have defined are Fast Ethernet 0/0.2, 0/0.3, and 0/0.4. Again, there is a script this time from the router's CLI, and it is the results that we are um, seeing uh, by entering the command show running config in the router. And we can see in these lines that subinterfaces have defined correctly and they are working properly. And now let's talk about a tag here, encapsulation.1q2, because multiple VLANs share the same trunk link. VLAN identification is required. IEEE 802.1q provides VLAN tagging, and this tag is added to Ethernet frames so that the router and switch can identify which VLAN the traffic belongs to. And this mechanism is essential for router on a stick operation. And now in the last page, we're gonna talk about IP addressing. Each VLAN uses a separate subnet. VLAN 2 uses the 192.168.2.0/24, and that's its network ID. And the default gateway is 192.168.2.1. And also we have similar addresses for VLAN 3 and VLAN 4 with this difference that it's 3.0/24 and 3.1, and here 4.0/24 and 4.1. You can also see these screenshots. They are from the IP configuration from PCs in different VLANs. For example, this is from VLAN 2, and it's from VLAN 3, and that's from VLAN 4. We can see the IPv4 address, subnet mask, and default gateway. And the router subinterfaces provide the default gateway addresses for these networks. And thank you for your attention. Now I would like to move to Cisco Packet Tracer and demonstrate the practical implementation and connectivity tests. Okay, so first let's verify the VLAN configuration. Let's enable the switch. Show VLAN brief. By using the command show VLAN brief, we can see all configured VLANs and the ports assigned to each VLAN here. As shown here, VLAN 2, VLAN 3, and VLAN 4 have been configured successfully. Now let's verify the trunk link by using the command show interface trunk. The output confirms that fast Ethernet 0/1 is operating as a trunk port, as the status is trunking, you can see here, and it is carrying traffic from multiple VLANs. As you can see here, VLANs allowed and active in management domain, it's all the VLANs. And now let's move to the router to verify the router configuration. First enable it and show IP interface brief. Now we can see the subinterfaces that were created for each VLAN. You can see here. Each subinterface functions as the default gateway for its corresponding VLAN. And now let's test the PCs. Okay. First, I will test communication within the same VLAN. Now I am in VLAN 2, and I am trying to communicate with PC 1 with this IP address. The ping is successful, as you can see, which confirms that layer 2 switching and VLAN membership are configured correctly. And now let's test communication between different VLANs. I am trying to communicate with a computer from VLAN 3. You can see that it was successful. And then VLAN 4. You can see that these were also successful. It confirms that inter-VLAN routing is functioning correctly through the router on a stick configuration that we used. And now let's test. Now let's ping a default gateway. As you can see, this is also successful. So now we can say that the connection between devices have been established correctly. And now let's virtualize the packet flow. Let's reach to simulation and here we can see that packet first reaches the switch, then travels through the trunk link to the router, where routing occurs, and finally reaches the destination device, which can be located in a different VLAN. And this simulation clearly demonstrates how inter-VLAN routing works in practice. And thank you for watching.